Hey everybody, today I'm going to be covering augmentation and data generators. This concept is very important in that when you're developing your models, often you won't have enough data, and using the augmentation technique, you can take your existing data and augment it or modify it, scale it, rotate it, and use built-in functions from Keras to be able to do that. That allows you to have, really maybe hundreds of images instead of thousands of images you may need for your application to get the level of accuracy that you need. So it's an important concept. It's taken from chapter 5. It's section 5.2.4, data processing, page 135 if you're following along. So let me just walk you through this. It's pretty straightforward code, but the concepts are very important. So I believe all my modules are already loaded, yes. And then I am going to load in my data set, MNIST data once again, and I'm going to use a function from Keras. So I'm going to import the, from sklearn. I'm going to use a module from sklearn called train test split. I find this useful in that it will divide up your data into a training set. I call it capital X underscore train, and then a test set, capital X underscore test, and then the labels, the targets, Y train and Y test. I've set it up to have a test size of 0.2, 20%, so 20% of the data. So if we have 60,000 images, 80% of them will be in the train set and 20% will be in the test set. And then I set this random state to a specific number. I see it's called a random seed. And I do that because if we had, forgot what the default is on this, but if we used another value, you may read in a random set of data every time. And what I want is the same set of data read in, so I set the seed. That way I get the same set of data, so I can compare my model, the accuracy model, the same set of training data and test data between models. So that's something for you to look into. Oh, and if you don't know these kind of tips and techniques, you can call up in your Jupyter notebook. You got to run the function first here. So that's a little tip, is if you haven't run it, then the contextual help is not loaded. And I did a shift tab, and now I can expand this. And if we want to learn more about the random state, here's the definition: random state, instance or none, the seed used to the random number generator. If none, the random number is the random state instance used by .rand. So it's a high-level method to ensure that I get the same data every time, and I can set it where it shuffles so that I can get new data. In my case, I want to get use the same data to test one model against another. All right, the next thing I'm going to do is, I often call this data exploration, is I'm just going to plot out the data I have and take a look at it. So let's run that, make sure everything loads properly. And yes, I have training samples of 48,000 images, and so that's 80% of the training data. And then the image size is 28 by 28, which we expect from the MNIST data. And I have 10 classes, 0 through 9. Okay, and here's some samples of those images. Now, the purpose of this lecture is really to kind of show you this cool tool called the Image Data Generator. And so this is taken from the Keras pre-processing, and I import the module called Image Data Generator. And it has several features, such as the width shift range, vertical flip, rotation range, and all these are different parameters that you can set to generate new data from the original data set that you have. And then run this, and then I'll do a shift tab, and we can take a look at some of the parameters. I've already set some, but you can go in here. There's a lot of different values: shear range, how much to zoom, the zoom range, channel shift range. Oh, you can, between channels, you can shift data, which is interesting. I have not used that feature, but that's an interesting feature that I'd like to use. You can flip the horizontal, the top part to the bottom part, and depending on your application, and we're looking at handwriting, we may want to take a look at which one of these parameters or attributes that we want to set to generate new data. So let's go ahead and run this. So I've run this, and here's an important note, is that it creates an object called DataGen, and then when I go train, I basically take the object and implement a flow method, and here's what the flow method does, and it describes what it does. Is it takes a batch of images, takes a data and label rows and generates batches of augmented data. So you have to implement this datagen.flow method. So this instantiates the object, and then to implement, to actually execute on the generation, you have to give it the parameters. In this case, I set batch size to 60, and I want to just output this new object called train generator that is a subset of my training data. Same thing for validation here. I've called this validation. So that gives you a little bit more details on how these functions work. And then the next thing I want to do is let's take that data and let's output the various images. Now notice this, I pulled off this image number 5, the same image, and then I've used the augmentation tool, DataGen object, generated the data, and then I pull off the data that's been generated, just the first image out of the batch, which is x_train0, reshape the data so that I could pass it in to this DataGen flow, right? And then plot the data. So I'm really just augmenting one image at this point to show how the functionality works. And you can see that we have now the image is the width. It's been moved in the width. I think I have the width set here to shift shift range is 0.20. So that's 20% of the image. In our case, that's 28 pixels times 0.20, so about 5 to 6 pixels. So you can see that shifted it off. It has a built-in feature called the fill mode, which is nearest. So if the image is shifted off the page, what it does is fills in the rest of the images, fills in the rest of the pixels to the image with the nearest value. So it has a lot of cleverness built into this function so that you can augment the data. So in our application, I think it's pretty rare that we would have maybe a rotation of 30 or 40 degrees. So you can come in, and I'm going to change that to 30, and maybe the shear range, which is kind of the bottom and the left half kind of shearing, the bottom and the top part shearing at some angle. So I don't think we have as much of that. And then the zoom range is a little bit lower probably. It depends on your application. So you set these values depending on your application, and rerun this, and you can see that the output will change when we go back to look at this. Okay, so those are kind of more realistic types of images that have been augmented using the augmentation functionality. All right, that is a very short intro to the augmentation. So ultimately, using this technique, and I've got a model that I've already created with this technique, very similar to what was just shown there. Now this model, I'm using 100 feature maps. Okay, so a lot of kernels, kernel size 3, importing the image and doing some max pooling here, also using 50% dropout. So this is a pretty sophisticated model here. And with this model, I believe I achieved close to 90% accuracy, above 93, 95% accuracy with this model using augmentation on the MNIST data. So augmented the data, used convolution 2D, used regulation. So I used all the things that we're talking about and created a model that's getting about 95, 93% accuracy. Here's the training and validation accuracy. And we can see that starting to flatten out at about 4 or 5 epochs here. And an epoch is when I run the model itself. It takes that batch, runs through all of that batch, and returns the accuracy, and does that over and over for each batch. And I set my batch size to 60 here. So an epoch runs through all of the images in the batch, and then returns the accuracy and the loss. So this is a good example here. I'm printing out the image ID, the predicted and actual, and then finally here I predicted a confusion matrix, and it shows that I'm missing, let's see, that's 7, looks like to be a challenge as being it's the predicted value, but it's actually a 9. So you have a few objects that are being identified as 9s that are actually 7. So that's how you use a confusion matrix. All right, so the intent of this short video is just to give you an introduction to the data generator that's a part of Keras, and be able to use that to augment your original data set to create new images that you can train and test against. All right, until next time.